LCM and GCF are super important, and that's why we're starting it before we get into fractions, because LCM is going to help us when we start adding and subtracting fractions with unlike denominators. The main thing you have to do when you're adding and subtracting fractions with unlike denominators is first make the denominators the same. And the way we do that is by using the LCM. So you're going to hear this term a lot over the next few weeks while we're working on adding and subtracting fractions. But we're also going to be talking today about GCF, which is the greatest common factor, which also helps us with fractions when we start to reduce and simplify, which is another expectation when working with fractions. So we're going to start with LCM first, and we're going to talk about a couple of vocabulary terms that you should be familiar with now after yesterday. Yesterday, we learned about a word called a multiple. What is a multiple? Can somebody refresh our memories? What is a multiple? You can look back. It's in your notes.
Sean, what about your dogs?
It's like skip counting. It's a number that you get after you multiply two factors together. So it's like a product. So basically, when we're looking for multiples of any number, we are going to skip count. So we're going to practice finding the LCM, or the least common multiple, of 6 and 8. So the first thing that we're going to want to do is we're going to list all of our multiples of 6 and 8. That means we're going to skip count, counting by 6s and 8s. So here I'm going to start with 6, and I'm going to list the first 10 multiples, starting with 6. So 6, 12, 18, 24, 30, 36, 42, 48, 54, and 60. I'm going to do the same thing for 8. So I'm going to skip count by 8s, and I'm going to list the first 10 multiples of 8. So I have 8, 16, 24, 32, 40, 48, 56, 64, 72, and 80. The second step in finding LCM is right here. I'm going to circle the common numbers, or the numbers that are the same. So the multiples that each 6 and 8 have in common. So I go down my lines, and I look to see I have 24. That matches. What's the next number that I get to that is matching?
48.
48. Is there anything else? I don't have anything listed, do I? But all I did was the first 10 multiples. If I kept going and I did 12 multiples of 6, what is 6 times 12? 72. So 72 would be another common multiple, but at some point I've got to cut it off. I got to stop, because multiples are infinite. They go on forever. So I'm going to list the 2 multiples that I have in common out of the list that I created, and that's going to be 24 and 48. Out of the 2 of those, which one is the least common multiple? 24. So this is considered my LCM. Now, that LCM is going to help us when we start comparing and converting fractions. When we talk about equivalent fractions, which is something we will get to soon, you're going to be using the LCM to create equivalent fractions. And I'm going to show you in just a second with this example right here how that looks. So what we're going to do is we are going to first make a little note. I'm going to put a little star, and I'm going to say find the number. I'm going to abbreviate number with the little hashtag symbol. So find the number that will make each denominator the LCM. Okay. So to the right, we have a note. It says finding the LCM is really very super duper important when comparing and converting fractions. So we're going to look at a couple of fractions and we're going to see how the LCM plays an important role. So I am looking at 1/8 and I'm going to be adding it to 1/6. Well, we learned in previous years how to add fractions when the denominator is the same. All you do is you add the numerator and the denominator will stay the same. But when the denominator is different, this is where LCM comes in handy. So what did we determine the LCM of 6 and 8 was? Do you remember? 24. So I'm trying to rewrite both of these fractions with 24 as my denominator. So I'm going to ask myself, well, how did I get from 8 to 24? What did I multiply 8 by to get 24? 3. So if I did that to 8, I have to do the same thing to the numerator. So what's 1 times 3? 3, and that becomes my new numerator. So what this means is if I were to draw, I'm going to do it over here on this side. If I were to draw a rectangle and split it up into 8 equal parts, and I shaded one of them, I could use this same size rectangle and I could divide it into 24 equal parts, which is going to be a lot. I'm not going to be able to do this very well. I need 6. Hold on. No, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So there's 24 teeny tiny little pieces. If I shaded 3 of those 1, 2, 3 of those 24 pieces, notice it's the same amount as 1/8. So that's what we're showing is equivalency. 1/8 is the same as 3/24. They are equal amounts. It's like taking a pizza. A whole pizza doesn't change, right? But you can cut it into different amounts. You can cut it into 8 pieces. You can cut it into 12 pieces. You can cut it into 16 pieces. So it's the same amount, but it looks different. Okay, now if I did the same thing to 1/6, I'm going to also write it with the LCM of 24. So 6 times what gave me 24? 6 times 4. So 1 times 4 is my new numerator over here. And now all I'm doing is 3/24 plus 4/24, which is 7/24. We're going to do a whole lot of practice with this over the next few weeks when we're adding and subtracting fractions, even a little bit after Christmas too, because it's a concept that takes a little bit to kind of really get a deep understanding on. All right, moving on down. All we're going to do today is we are going to practice finding LCM of 2 different numbers. So I have 2 and 4. The first thing I want to do is list all of my multiples of 2. Is that possible to list them all?
No.
No, because they're infinite. They go on forever. So I'm just going to list them until I run out of room. So 2, 4, 6, 8, 10, 12. For 4, I'm going to list out 4, 8, 12, 16, 20. Of the ones that I listed, do I have any multiples that are in common? 4, 8, 12. What is my least common multiple? 4. Okay, now for 8 and 5, same thing. I'm going to skip counting by 8s. 8, 16, 24, 32, 40, 48, and now I'm going to skip count by 5s. 5, 10, 15, 20, 25, 30. I have to keep going. 35, 40 until I get a common multiple, which is 40. It's also my least common multiple. So my LCM for 8 and 5 is 40. What do you notice about 8 and 5 and the least common multiple?
8 times 5 is 40.
Yeah. So if you multiply the 2 numbers that you're looking for together, you will get a common multiple. But will it always be the least common multiple?
No.
Not always, because if you look over here at the first example, 2 times 4 is 8. but my least common multiple is 4. So it won't always work, but sometimes it does. Okay, I want you and your group to try the last two, and then we're going to check it together. Okay, this is what hopefully you have on your paper. Maybe you have less, maybe you have more multiples, depending on how big you wrote or how small you wrote, but the LCM of 4 and 6 should be 12. LCM of 3 and 4 should be 12 also.
3 times 4 is 12.
All right, moving on down, last two things. We're going to define what common means and what a multiple is. So common means shared or same as another. And a multiple is the number I don't like the way that this is defined. How did I do it earlier? Hold on. I wrote it down because I liked this better. I said the product, so I'm going to change this. The product of a number multiplied. And what you need to remember with multiples is that we are skip counting. Okay. The next thing we're going to talk about is GCF. It's similar. They're easy to confuse, but it's just as easy as LCM. You just have to pay attention to what you are being asked to do. Okay, looking at GCF. We are going to use a T-chart in order to find our greatest common factors. So least common multiple we just did. Now we're focusing on greatest common factor. Here is an example of our T-chart right here and what it will look like. Okay, you have your product at the top of your T-chart, and then you have a factor and another factor that equal this product. We're going to list all of our factor pairs that make this product. So in that first blank right here where I was just pointing, we're going to list all pairs of factors. The first pair is always going to be 1 and the product, because 1 times a number is going to always be that number. So whatever your product is, we'll always start with 1 and the product. Then we'll try 2, see if you can multiply 2 times something to equal that product, and then 3, and then 4, and we'll keep going and going until we can't anymore. Remember your divisibility rules. If a number is already listed in your factor tree or your T-chart, then you can stop. If it's a twin, meaning we already have it listed, or it's a matching one, then we can stop there too. So you're going to see a couple of different examples of that here in just a minute when we start doing some. Okay, moving over here to the right side, it says use a T-chart to list the factors. We're going to practice with the product 4. So I have 4 at the top of my T-chart, and I'm going to list my factors starting with 1 and the product 4. So 1 times 4 we know equals 4. Then I'm going to go to 2.
2 times 2.
2 times 2. If I listed 3, is there a number I can multiply by 3 that equals 4?
No.
No, so that one's not going to work. What if I did 4? Well, it's already listed, right?
Yeah.
So that's where it's repeating, and I don't need to do it again. I used to also call this the horseshoe method when I taught this a long time ago, because it kind of wraps around like a horseshoe. Once I get to 2, it loops back around. So it's like the horseshoe method also. Okay, so over here, we're going to fill in these blanks. It says something about a common factor. So you need to know that a common factor is a number that is a factor of 2 or more numbers. So a common factor is a number that is a factor of 2 or more numbers. So I have an example here. It says 2 times 3 equals 6 and 2 times 2 equals 4. So I have some common factors. What are my common factors in both of these? 2. 2 is my common factor in both of those. So those are considered common factors. Okay, we're going to do a couple of examples together. I have the GCF of 36 and 48. We're going to do this one first. So I'm going to list all of the factors that I can think of for 36, starting with 1 and 36, because I know that 1 times 36 equals 36. Can I multiply 2 by something to equal 36? Yes, I can. It's 18. So 2 times 18 equals 36. What about 3? 3 times 12 is 36. What about 4? 4 times 9. What about 5? No. What about 6? Yes. 6 times what? Okay, notice how it is a twin here. 6 and 6, those are twins. So now I stop. Because if I were to keep going, 7 doesn't work, 8 doesn't work, and then I'm to 9, but I've already listed it, so it's looping back around again. So I'm going to list out all of the multiples, least to greatest. I have 1, 2, 3, 4, 6, 9, 12, 18, and 36. Now I'm going to do the same thing for 48, starting with 1 and 48. Then I go to 2. 2 times what equals 48? 24, right. And then 3 times 16, 4 times 12, 5, nope, 6, yes, 6 and 8. And 7 does not, and then it repeats. It loops back around. So now I'm going to list all of these factors. So I have 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48. So what I'll do is I will circle all of my common factors. I have 1, 2, 3, 4, 6, 12. Any others that I have in common? I think that's it. Okay, what are all of my common factors? I have a lot. 1, 2, 3, 4, 6, and 12. But my greatest common factor is what? 12.
So that's basically the whole thing?
That's what you're doing to find greatest common factor. Okay, we're going to do this one together. It's shorter, and then I'm going to have you and your group do the very last one at the bottom. Okay, my factors for 21. Always start with 1 and the product itself. So 1 and 21. 2, does 2 divide into 21 evenly? No. What about 3? 3 and 7, and that's it. So when I list out those factors, it's just going to be 1, 3, 7, and 21. For 35, I have 1 and 35. What else do I have? 2 won't work. 3? 5. Bryn's showing me 5. That's right. 5 times what?
7.
Yeah, and that's it. So it's just 1, 5, 7, and 35. So my common factors, I'm going to circle. I have 1 and 7 that they have in common, but the GCF is going to be what? Right, 7. Okay, I want you and your table to do the last one together for 4 and 8. You're going to find the GCF of 4 and 8. List them in the T-chart. Then list them out horizontally. Circle the ones they have in common. And then give me the GCF. And then we'll check it.
And the greatest one is 4.
All right, here's what I have. You should have something similar. I have 1 and 4 in my factor tree, 2 and 2 for my product of 4. And then for 8, I have 1 and 8, 2 and 4. I list them out. I have 1, 2, and 4 for 4, 1, 2, 4, and 8 for 8. I circled all of my common factors and I listed them out and noticed that my greatest common factor that they have in common is 4. Okay.